Hello and welcome to the Data Structure and Algorithms online tutorial video. In the last video, we discussed what is B-tree and its properties. And in this video, we will discuss how to create a B-tree of order 4. Here we are going to create a tree of order 4. Therefore, m is equal to 4. And maximum key values that a node can have is m minus 1. That is 4 minus 1 is equal to 3. Consider an array of integers. First, scan the given set of numbers from left to right. We can start inserting the elements, but before that, let's create a node first. And this node can have maximum 3 keys. Because m is equal to 3, so maximum a node can have only 3 keys. And here we insert the first element, that is 6 in the first position. Next number is 4, but we cannot insert 4 in the next place. Because as we discussed in our previous video that B-tree elements are in sorted order. Therefore, in the first place we will insert 4 and next insert 6. Next number is 22. 22 is greater than 6, so it will be inserted next to 6. Now coming to the number 10, let's see where it can be inserted. 10 is greater than 6 but less than 22. So the place of 10 would be after 6 but before 22. But we cannot keep it here because here we can insert only 3 keys. So in this case, we will find out the median of these numbers. I mean middle number of the node. And the middle number will go one step above. That is, the middle number will be the root node. We have to find out the middle number out of numbers 4, 6, 10 and 22. The middle element can be either 6 or 10 because these two numbers are in the middle position. When you take 6 as the middle element, 4 will be the left child node and 10 and 22 will be the right child nodes. When you take 10 as the middle element, then 4 and 6 will be the left child node and 22 will be the right child. Both are correct. We can take any of these, and this happens when numbers are even in count. This is called left biased and this is called right biased. I will go with left biased and make 6 as a root node, so the tree would look like this. Now moving to the next number, that is 2. Let's see how we can insert 2. 2 is a new element and all the new elements can be inserted in the leaf node itself. You cannot insert in the root node. But first we will compare the new element with the root node to decide which subtree does it go to, that is right or left subtree. 2 is less than 6, so it will go to the left subtree. And as it is less than 4, so it will be inserted before 4. Next number is 14. 14 is greater than 6, so it will go to the right subtree. Here node is already having 10 and 22. 14 is greater than 10 but less than 22. So it will be inserted in the middle of 10 and 22. Now next is 3. Let's find out where we can insert 3. 3 is less than 6, so goes to the left subtree. And in the left subtree, the existing numbers are 2 and 4. 3 is greater than 2 and less than 4, hence 3 will be inserted in between. Next element is 8. As it is greater than root, it goes to the right subtree. It is supposed to be inserted before 10, but we cannot insert there because maximum we can have only 3 keys in a node. So again we have to split and find out the middle value out of 8, 10, 14 and 22. Middle elements are 10 and 14, but we cannot take 14 as the middle element because we are creating the left bias tree. So here 10 will be the median and it will go to the root node. And in the root node we have only one key value, that is 6. So we can insert 10 in the root node. After splitting the node, the tree will become like this. 8 will be the left child node, 14 and 22 will be the right child node keys. Next element is 11. It goes to the right subtree and it can be inserted before 14 as it is less than 14. Next we will compare 13 with the root node keys. It is greater than 6 and 10, so goes to the right child node of 10. And here it is having filled with all 3 keys and maximum we can insert only 3 keys per node. So again we will find out the median out of 11, 13, 14 and 22. So the middle elements are 13 and 14. We will take 13 as a median because we are working on left bias tree. So 13 will be inserted in the root node as a root node is having one more space empty in a node. As per ascending order, 13 will be inserted after 10. After splitting the node, 11 will become the left child node, 14 and 22 will become the right child node keys. Next is 5. And 5 is less than 6, so goes to the left subtree. Here it is supposed to be inserted after 4, but already 3 keys are filled. So again we will find the median out of 2, 3, 4 and 5. 3 and 4 are median numbers and we will take 3 as a median because left biased. But already the root node is filled with 3 keys. Now find out the median out of 3, 6, 10 and 13. So we will go with 3, but as we know that the root node is already having 3 keys filled. Therefore, we cannot insert 3 in an existing root node. So we will have to find out median out of 3, 6, 10 and 13. Here 6 and 10 are median, but we will take 6 as a median because in the beginning we selected to go with the left biased. Therefore, we will have to go with the left biased in the whole creation of B tree. So 6 will go one step up and it becomes the root node. And after splitting of the node, the tree will look like this. Now the last number to be inserted is 9 and 9 is greater than 6, so goes to the right subtree. In the right subtree's root node we have 10 and 13 and 9 is less than both, so it will go to the left child of 10 and there we have 8. As 9 is greater than 8, it will be inserted after 8. So this is how we create a B tree. Please like the video, subscribe to our channel and please hit on bell icon to get notified whenever we post new videos. Install DSA application from the Google Play Store or from the link given in the description below. Please let us know if you have any queries in the comment section below, and thank you for watching.